Jai Hind everyone. So this is Shreya Chaudhary and I am back again with some new topic that we are going to discuss today. And this topic is related to the IB board and the topic is quantum and nuclear physics. That is the name of the chapter. The topic we are going to take today is Bohr's model of an hydrogen atom. The topic is Bohr's model of an hydrogen atom. So let me write the topic name and then we will start with the topic. Okay. Uh, Bohr's model. Bohr's model of an hydrogen atom. This is the topic we are going to take today, and this topic is an IB board. IB board. The name of the chapter is quantum and nuclear physics. Nuclear physics. HL. Okay. So let me discuss first what Bohr has proposed, what is his postulates about the model of an hydrogen atom. He has given his postulates in three different points. The first point is every atom consists of a central core known as nucleus, where the entire mass and entire positive charge of the atom is being concentrated, where the entire mass and entire positive charge of the atom is being concentrated. The electron will be revolving around the nucleus, and the electron will be experiencing a centripetal force due to the nucleus. This centripetal force is provided by the electrostatic force which is acting between the nucleus and the electron. I am repeating again, electron will be experiencing a centripetal force which is provided by the electrostatic force which is acting between nucleus and the electron. Hence, the equation for the Bohr's first postulate is given by, I am writing only the equations, and as far as the statement, I am discussing the statements. Okay. So the first equation we are going to write over here is the centripetal force mv square by r will be equals to kz e square upon r square. Hopefully you are very much familiar with the value of kz e square upon r square, where r is the radius of the circular path, z is the atomic number, e is the charge of the electron, and k is the constant. Okay, so let us take this as equation number 1. This equation has came from Bohr's first postulate. Now let's go for the second postulate. Bohr said that electron will be revolving in those orbits only which are non-radiating in nature. I am repeating, electron will be revolving in those orbits only which are non-radiating in nature. These orbits will be termed as stationary orbits. These orbits will be termed as stationary orbit, and the angular momentum of the electron, will be equal to integral multiple of h upon 2 pi. I hope I am very much clear that the total angular momentum of the electron will be equal to the integral multiple of h upon 2 pi. So the formula of angular momentum is mvr equals to integral multiple, n is the integer, integral multiple of h upon 2 pi. Equation number 2. Let's moving to the third postulate. Bohr postulated that whenever electron jumps from lower orbit to higher orbit, what I mean to say is inner orbit to outer orbit. Suppose the electron is in its ground state, okay, K. Now from K, the electron has jumped to N shell by absorbing some of the energy. So whenever electron jumps from lower energy level to higher energy level, it absorbs the energy. and that energy will be equal to h nu. However, whenever electron jumps from outer energy to inner energy level, it will releases an energy which is again equal to h nu. I am repeating the statement that whenever electron jumps from lower energy level to upper energy level or higher energy level, it will absorb an energy equal to h nu. And whenever electron jumps from higher energy level to lower energy level, it will releases an energy equal to h nu. Hence, the equation will be given by h nu is equals to E2 minus E1. That is your equation number 3. So we got three equations. The first equation is related to the centripetal force and the electrostatic force. The second equation is related to the angular momentum and the integral multiple of h upon 2 pi, whereas the third equation is related to the release of energy or absorption of energy whenever electron is jumping from lower energy level to higher or higher to lower, vice versa. So now we need to find the value of r, that is the radius of the circular path in which the electron is revolving. Okay, so let us find the value of r from equation number 2. Let's move in. We need to take the value of v actually. So from equation 2, let me write down over here. From equation 2, v will be equals to nh upon 2 pi mr. This is the value of v from equation number 2. As we can see over here, v is equals to nh upon 2 pi upon mr. So we got over here. Let this equation be equation number 4. Putting equation number 4 in equation number 1. Again, let us see what is equation number 1. Here you can see the equation number 1, mv square by r is equals to kz e square upon r square. So let's put the values. M upon r, in place of v, we will be having nh upon 2 pi mr whole square equals to kz e square upon r square. On rearranging, m n square h square upon 4 pi square m square r square. This r will be kept over here, kz e square upon r square. So on cutting these values, we can cancel out these values. On cancelling m with m, we will be left with, what will be left with? Let us see. R will be equals to n square h square upon 4 pi square m k z e square. This is the value we left with. Okay, so now if we see, then the variables in this equation will be n. N is the variable because we don't know in which orbit the electron is revolving, as well as z is the variable because we don't know which element we are going to take. Since it has already been discussed that Bohr's model of an hydrogen atom, that's why we can say that z equals to 1. The atomic number of hydrogen is 1. That's why we are going to put z equals to 1. In the similar way, we do know the values of other as well, because h equals to, h is the Planck constant. The value will be 6.63 into 10 to the power minus 34 joule second. 4 pi square is a constant value that we know very well. Mass of electron that we know 9.1 10 to the power minus 31 kg, and E is the charge of electron 1.6 10 to the power minus 19 coulomb, and the value of K is, let me write down, the value of K is 9 into 10 to the power 9. On putting all these values in the previous equation, we will be getting n square 6.63 10 to the power minus 34 whole square upon 4 pi square. In place of m, we should write down 9.1 10 to the power minus 31. The value of K is 9 into 10 to the power 9 into z is 1, and again e 1.6 10 to the power minus 19 whole square. Even if we keep all these values, we will find the value of r as 0.5 into 10 to the power minus 10 n square meter. Now if the value of n is equals to 1, then the r will be 0.5 into 10 to the power minus 10 meter. This is the value of r we will be getting. This is the value of r we will be getting. Okay. So till now we got the value of r. Till now we got the value of r. Now we need to focus on how much energy we do require. How much energy we do require, or what is the total energy of the electron. We should specifically say what is the energy of the electron. So for the energy of the electron, let me write down, for the energy of electron revolving around the nucleus, around the nucleus, total energy will be equals to potential energy plus kinetic energy. Okay, so when we talk about potential energy, since the electron is situated at a certain distance of r from the nucleus, then the potential energy that we will be getting over here will, already we have studied that in capacitance or electrostatic potential. Okay, that chapter electrostatic potential, we have studied the value, and the value will be minus k z e square upon r. This is the value of potential energy of the electron. Okay, for the kinetic energy we will be having half mv square, and that is a very common equation. The value of mv square, only mv square, we will be getting the value of mv square from the very first equation we have written over here. As you can see in slide number 2, mv square by r is equals to kz e square upon r square. On cancelling r with r, we will be getting, let me write down from equation number 1 in slide number 2, from equation 1 in slide 2, what we will be getting, mv square by r equals to kz e square upon r square. R and r will be cancelled out. mv square will be equals to kz e square upon r. Putting the value of mv square in the previous equation, in the previous slide, the value of kinetic energy will be equals to half kz e square upon r. This is the value of kinetic energy we will be getting. Okay, so for total energy, what we will have, we will be having potential energy, that is minus kz e square upon r, and the kinetic energy half kz e square upon r. On solving, we will be getting minus kz e square upon 2r. Hopefully it is quite easy. On taking the LCM, we will be getting the answer, that is minus kz e square upon 2r. This is the value of total energy possessed by the electron. Again, if we put the value of r, what is the value we are going to get? Let us see. Total energy will be equals to minus kz e square upon 2. In place of r, we are going to put the basic terms of r that we have just figured out in the slide number. Let me tell you, in the slide number 5. In the slide number 5, as you can see, in place of r, n square h square upon 4 pi square m kz e square. Okay, this is the value of r. Let us just tally it. N square s square 4 pi square m kz e square. Okay, so again, on rearranging, that we have to rearrange it for the better calculation, minus 4 pi square z square k square e to the power 4 m. This is what we have. 4 pi square I have written, z square I have written, e to the power 4 written, k square. Okay, very well, and m. So in denominator we will be having n square h square. Okay, 2n square h square. On solving these whole, let me tell you, this value is unknown and this value is unknown. Z is unknown and n is unknown. But for the hydrogen atom, again, Z is known. The value of Z is 1. Okay. So on putting all the values again, the value of K, the value of E, the value of M, mass of electron, charge of electron, the value of K, Planck constant, all these values we are going to keep, and we will be having the value of total energy as minus 21.76 into 10 to the power minus 19 upon n square joule, keeping Z equals to 1 for hydrogen atom. Okay, this is the value, minus 21.76 into 10 to the power minus 19 and upon n square joules. When we figure out this value in terms of electron volt, the value will be minus 13.6 upon n square electron volt. This will be the final value we will be calculating. This will be the final value we will be calculating. This is the total energy of electron when the electron will be revolving around the nucleus in terms of electron volt. And in terms of joule, this is the answer that you are watching on the screen. That is the minus 21.76 into 10 to the power minus 19 upon n square. So hopefully you all have understood this topic. You can go through these slides, this video again and again for the better concepts and for better understanding. Thank you.